And charot. Okay, so welcome back to my YT channel. This is again your YouTube content creator, Science, Health, Safety, and Music. Okay, our topic for today is listing of different or various atomic masses and atomic weights of popular, or should we say not quite popular, elements in the periodic table. Okay, so we will start this from the left to the right, from the top to the bottom, with directional positioning of this particular block. Okay, now we have here the most and VIP, most valued, important person, right? VIP, or the given special treatment above all things, which of all elements, rather, the important gas in the universe, the lightest gas in the universe, discovered by Henry Cavendish. Ladies and gentlemen, hydrogen! Okay, hydrogen with atomic mass of 1.008. Okay, things like that. Hydrogen is a gas naturally built in or naturally present in the Proxima Centauri, which is our sun. The sun is the center of the solar system in our universe, and the sun weighs 1.989 times 10 raised to the power 30 kilograms. So this is very weightful or very heavy compared to our planet Earth. Our planet Earth has a mass of 5.975 times 10 raised to the power 24 kilograms. So since 24 exponent is lesser than to the 30 exponents, so it is safe to say that the weight of the sun is more heavier than our planet Earth. Am I correct? Correct me if I'm wrong. Okay, we will not focus on the numerical figure, but rather thinking that our sun is heavier than our planet Earth. So going back to hydrogen. Hydrogen is very useful in fueling a rocket, things like that. In fueling also the missiles. It needs higher energy of hydrogen gas to really activate that very fast energy to the universe and in the outer space. And then this hydrogen undergoes the process of nuclear fusion. As we can remember, our basic foundation of our general chemistry lecture 1. Okay, nuclear fusion, meaning the combination of one or more lighter materials or smaller materials into larger materials. Or how can we say this? A combination of very small particles to a larger particles. Or let us say smaller energy to higher energy. So it depends on our context of our definition. But it looks like from smaller to larger, from lesser to, let us say, larger, right? Lesser to larger. Okay, things like that. Okay, so nuclear fusion. Nuclear fusion and nuclear fission. Okay, the nuclear fission from larger to smaller, meaning to say split half of different molecules. Okay, so it's better to say that we are referring to molecules here, right? Okay, so we can say it's the process of decomposition, splitting, and broken down of larger molecules to smaller molecules in terms of radiation, nuclear radiation. That's why nuclear fission. But nuclear fusion, rather, it's also the reverse. Okay, the combination of smaller molecules or particles into larger molecules or particles in the context of nuclear radiation, things like that. So, any questions so far about nuclear radiation, which has two types? We have nuclear fission and nuclear fusion. Now, the process here in the sun is nuclear fusion specifically. So, let's explain this gradually. Okay. Any questions so far, class, for this? Okay, nuclear fusion or fusion. Okay, so if the question in the future will say, what process during the conversion of hydrogen into helium? Okay, so you will say nuclear fusion. Okay, things like that. So we have here the H plus with a proton of positive 1. It is, or it was, because it happened in the past, that Mr. Ernest Rutherford discovered the existence of the proton as an elementary particle of an atom. So, if the question will say also in the future, who discovered proton? Your answer will be Ernest Rutherford. Ernest Rutherford. But the question will say, who discovered hydrogen? Your answer will be Henry Cavendish. Henry Cavendish. Now, going back to hydrogen. The hydrogen undergoes multiple of transformations. So, start from a positive 1, okay, charge which is called proton. Proton, okay? Then after that, it will intensify or enhance to have more energy and elevate it to H positive 2, which is deuterium. Okay? So, after that again, it builds up higher energy to raise the charge to positive 3, and this will be H positive 3 tritium. Okay, tritium. Now, thinking about that, how many isotopes does hydrogen have? So that's 3, right? Things like that. Okay, after that, it will build energy again and again and again and again. Now, it will be converted into helium. Okay, things like helium, positive 4. Okay, things like that. Okay, atomic number. No, it's not positive 4. 4.002 the atomic mass of helium. Okay, things like that. But if you try to look at it, so the leveling of helium and hydrogen, it is in the same period, the same level, the same orbit, or the same shell. Things like that. You got the point? Okay, so if you check your periodic table, correct me if I'm wrong, they are really aligned. So meaning to say, the atomic number of helium is 2. Okay, because the atomic number of hydrogen is 1, going to the right. So 1, 2, 3, 4, 5, like that. Okay, so it's gonna be 2. Now, I'm not really that sure. Correct me if I'm wrong. Okay, but I'm really specific and sure that the atomic mass and atomic weight of helium is 4.002 gram per atom. Okay, now, what is the purpose of helium? The purpose of helium is for putting that or diluting that to the SCUBA, self-contained underwater breathing apparatus, especially used by the divers who did dive underwater, okay, or under the sea, right? So it's gonna be self-contained underwater. The underwater here represents the sea. Okay, then breathing apparatus. So scuba, scuba, scuba diving. So that's the definition of scuba. Self-contained, past tense, underwater breathing apparatus. Okay, so what is the composition for this? So they add helium. They dilute the helium gas so that there will be an adjustment for the breathing and inhalation purpose for that diver if they will go very deep into the sea. Things like that. So what will be the composition for that? So it's going to be 38.2, let's say oxygen percentage by volume, things like that, no? Okay, then we have also 56, like that, 0.2. It's gonna be the nitrogen, like that. You get the point, mga palangga kong hitad. Okay, then how many left? 100. So 100 minus 26 minus, let's do the approximation here because this is gonna be just an approximation in understanding, right? Because it's not very specific, only for something. Calculator, please. Where is my calculator? Where are you? Okay. I'm here. Really? You are there? Yes. Okay. So we have here 100 charat. Okay. Chararat. Okay. 100 minus 56.2 chuvas minus 38.2 chuvas. Okay, things like that. Gonna be like that. So we will raise our oxygen to something. Okay, raise our oxygen to something, let's say 38 plus. Raise our nitrogen. Okay, nitrogen, we will lower the nitrogen. Why? Because if the nitrogen concentration is very high, it will go to the bloodstream of the divers. Then it can cause anoxia. Then it will suffer a very dangerous situation under the water. So with adding helium inside the gas cylinder, the scuba, then the nitrogen will be lesser. Okay? From 79% or 78%, it will become 56 chuvas. Like that. You get the point? Okay, so ang mahabili niya, mao ang charot, helium. So 100 minus 56 minus 38 ganon. So ang helium mo'y sobra. Okay, so these are the diluted helium out of the 100%. Okay, things like that. You get the point, mga palangga kung hitan, mga around 7 to 11% helium here, because the other helium will be diluted to the oxygen percentage by volume. That's why the oxygen from 21 will be raised to 38 to add more oxygen, but the nitrogen will be lesser to compensate the nitrogen concentration by the diver consumption under the water. So that's the purpose of helium, to support the breathing in under the water. Okay, things like that. So this will be common in different examination in the future. This will come out every time. Okay, the helium, even in the quiz bowls like that all over the world. Because I'm also a fanatic of, you know, world quiz, especially science quiz, math quiz in RPN Channel 9 in our local TV network. I love to watch those programs, educational, informative programs, especially the, the Battle of the Brains hosted by David Selbrad in RPA 9. I always watch that, competing different universities and schools in our country of origin, the Philippines, like that. Cebu will be competing to another region, Mindanao will be competing to the Luzon area, like that, and there will be also semi-finals, grand finals, and finals, and I enjoyed a lot. Okay, some of the information I obtained there also during the theory questions. I also use that in my vlogging. Okay, not all the time coming from my education, but also I really pick that for the different educational quizzes, programs like that before in the past. But now they are not focusing now with the educational programs. Okay, I think so. There's no such like that now, right? In the present situation or nowadays, I think so. Nothing, right? Okay, it was really phased out by other programs. Okay, now going back here, so the process here is. The process here, okay guys.
The Bluetooth device is ready to pair.
The process here is nuclear fusion.
The Bluetooth device is connected successfully.
Okay guys, so let's do it one by one, no mga palangga kong hitad. Okay, ganon. So, unsa may ato mga reaction ini. Chares. Okay. So, ang atong buhaton karon, we are now in the nuclear fusion. Charis. Okay. Tarara. Okay, so ang atong buhaton karon higayon na mga palangga. Okay. So, atong mapamatud-an karon.
The Bluetooth device is connected successfully.
Okay guys, are you still there? Okay, ano ba makaroon kayong lahat guys, no? So please forgive me because my music really dominates.
The Bluetooth device is ready to pair.
Okay.
The Bluetooth device is connected successfully.
Hello? Hello? Are you still there? Hello? Hello, mga kapuso? Kapuso, kapamilya, kapatid. Okay, so that is hydrogen. Too much with hydrogen introduction, right? An overview. Okay, things like that. Okay? And hydrogen also is very important in the natural production of water. Okay, we have We need 2 atoms of hydrogen in order for us to have water to drink every day. How many atoms we need? 2 atoms of hydrogen so that we can have water to drink naturally. Okay, things like that. If no 2 atoms, then there will be no water in the planet Earth because that's the requirement. 2 atoms of hydrogen. Okay, things like that. Now, if we try to have the chemical reaction for that, so we have hydrogen gas coming from the sun plus oxygen gas coming from our atmosphere. So these are all gases. And how marvelous and splendid, extraordinary, amazing, stupendous, what else? Higher superlative adjective. Awesome, things like that. Amazing, remarkable, exceptional. Okay, our Almighty God really is. Okay, because adding hydrogen gas is a gas, plus oxygen gas in the atmosphere and gas in our sunlight. Okay, then why it produce water which is a liquid? What's the sense? What's the logic? So, how can a gas will become liquid? You don't put any process there. That's natural. We don't heat. We don't condense. We don't have the process of condensation. So, it looks like a magic, right? Even the scientists cannot explain why that the hydrogen gas will be added to oxygen gas will produce water. This is natural. So, this is unexplainable to our nature that our Almighty God created. And we are very, very blessed to this. Okay? Because water is a renewable source of energy. Meaning to say it will never be consumed. The people will die, water will not be vanished in the planet Earth. Will not be disappeared because this is a renewable source of energy. You got the point. Now, our product here is water is liquid. How come? You add gas and a gas to produce liquid. Supposedly, it will produce a gas. Can you explain? Nobody can explain. I'm not also a scientist, but I'm just only a fanatic of science in my science world, right? So this is going to be the water. Okay, so you will try to balance the chemical equation, and this is reversible chemical reaction. Okay, reversible chemical reaction. This is a type of reaction in terms of forward and backward, meaning direction, magnitude and direction. Okay, things like reversible and irreversible chemical reaction. But this is reversible, meaning natural. It will goes back to water again, and if you reverse, go back again, unless you will apply an external source of energy to produce, hydrogen peroxide. Because if you split the water for the purpose of artificially, then you will produce agua oxinada or hydrogen peroxide sold in the market. Okay, but we are not talking of artificial process. We're talking here of natural process. So we will be abiding the reversible chemical reaction. Now, balance the chemical equation. Okay, 2 atoms of hydrogen, 2 atoms of hydrogen, and 1 atom of oxygen. So take note, if there is 1 atom here, you're gonna add 1/2 oxygen gas here. So that's why we have the water. So the water we drink is really 1 mole of water or 1 molecule of water that contains 2 atoms of hydrogen and 1 atom of oxygen. So the requirement is very clear. 2 atoms of hydrogen and 1 atom of hydrogen. If it exceeds 2, there will be no water. If it is less than 2, there will be no water. And this is what we are trying to give thanks to our Almighty God, because it looks like specific and particular. It will never change the molecule of the water. Okay? And apart from that also, we are also blessed that water is a polar molecule. Okay? Because when it is polar, it is highly conductive. Okay? So it will produce electricity and action potential in our body, in our central nervous system. Because without water, how come there will be an electrical impulses to create the neurons activation in different neurotransmitters in our brain cells? So imagine without water we will die. Because of course, 75% composed in our body. And at the same time also, in a larger perspective, the planet Earth also composed of 75% of water compared to the land. So let's give thanks to our Almighty God in this respect. And we are very, very thankful. Bravo! Okay, going back to hydrogen. Next, we have lithium. Lithium atomic mass is 6.92 gram per atom. Okay, just listen carefully, and if you will be able to write down that in a blank sheet of paper, class, then you write it, and then later memorize it day by day, because you will be able to use that in your chemistry subject, especially if you are taking up BS chemistry, BS medical technology. MedTech also have so many chemistry, and also medical science subjects, the doctors, physical therapy, like that. We have so many chemistry also. The same with us also, chemical engineering students. Okay, so memorize at least 50 elements. Okay, so that we will be happy if there are problem solving related to the molar mass, number of moles, like that, whatever, chupa chucho. Okay, so we have potassium. Potassium is, okay, 39.8. Okay, things like that, grams per atom. Charot. Okay, so what is our sodium? Okay, let's have 39 only for the benefit of the doubt. Things like that, because the point something will not matter that much. Okay, let's say 0.1 to 0.8 or whatever. So it's gonna be, we will start in 0.1. Okay, so 39.1. Really? Yes, it's gonna be like that, no? Okay, sodium 23. Okay, ganon. Okay, cesium will be 138.9 gram per atom. Ganon, right? Okay, we have also the francium. Okay, francium, Fr is equal to 223 grams per atom. Ganon. Okay, now, you miss one, right? Because the arrangement of atomic mass will be from top to the bottom will increase, right? So it's gonna be somewhere here from sodium and cesium. So it's gonna be, rubidium. Yes. Rubidium Rb is equals to 85.47 grams per atom. And that completes our group 1A alkali metals atomic masses. Okay. In 2018, there is also new element discovered by Mr. Hideto from Japan. So we call that as iodonium, UUE. And they plan to put an atomic number of 119 after 118, the unonium, right? So they plan that because we have only 118 elements. Okay, now they prepared a lot to the extent that they have also assigned atomic mass of this unonium, which is 316 gram per atoms. But it was not reflected fully in the textbooks in different universities, institutions, and schools all over the world, because they will have to agree again and again and again by the United Nations group of scientists all over the world before they will be able to accept and put this or reflect this in the textbooks worldwide. So until now, this unonium still a hypothetical element ready to be added after francium. So this will be called ika-francium, meaning to say it follows, then we can put another row. Later on, let's say 2025, 2026, 2030, our future generation will enjoy that. Okay, later, if they change now the periodic table by the addition of ika-francium, meaning next to francium. Ika is Greek term. Ika, Greek. Just like saying alpha, beta, omega, epsilon, rho, micro. Okay? Things like that. Okay? Micro. Okay. So the same thing, Greek symbol. So ika, francium meaning next. Okay. So this will be assigned here. Okay. But for now, not yet legit and not yet declared, but ready. So for now, mga palangga, we still have 118 elements, and the last element discovered is still unonium, discovered in Dubna, Russia. Okay, things like that. You get the point? And this is really discovered by Organician, Mr. Organician. Wow, okay, in 2012. O, diba? Yuri Organician is the scientist who discovered the last element in the periodic table in 2012. Okay, that is the history behind why this last element existed in the periodic table. Okay, now let's go to group 2A in the declaration of atomic masses and atomic weights. Are you ready? Yes, of course, we are ready. Okay, things like that. Group 2A. This is alkaline earth metals. That's why we have alkaline solution because most of them coming from calcium, like that. Okay, get the point? So that is alkaline, alkalinity. Okay, in fact, our blood is alkaline from 7 pH to 8. So if it goes beyond 8, problem. That is too basic and we will get sick, then we will die. If it is also less than 6, our pH of our blood, then problem. We will die also. So we maintain our blood in alkaline level between 7 to 8, things like that. So be careful in drinking regular soft drinks and other soft drinks because it will produce methanol, things like that, especially if the process is not clean. I know their process, they will eject and reject methanol somewhere along the way, but I told you there's no perfection of the process. There's still bacteria, whatever, especially if the containers, vessels, tanks are not clean, then it will trigger the presence of bacteria, it will increase the methanol, and it will go to the drinks that we eat, that we buy in the market or whatever. Then it produces methanol, converted to formaldehyde, converted to formic acid, and the formic acid will increase the level of our alkaline blood. It will become acidic. Okay? Things like that. So be sure also that you have a higher level of carbonate, sodium bicarbonate, to balance the alkalinity of our blood. Again, our blood is alkaline. It's not acidic, it's not basic. Okay, it's the range between 7 to 8. So once it will become acidic, we will die. Once it will become basic, we will also die. Okay, that's very clear. Okay, go back. Okay, go back to the group 2A. Charots. Okay, our group 2A alkaline earth metals, on the top will be the beryllium. Okay, beryllium Be is equals to 9.02 gram per atom. Okay, things like that, right? And then we have also calcium, okay, 40.08, things like that. Strontium, okay, SR is equal to 87.62, diba? Okay, we have also barium, Ba is equals to 137.3, and we have radium, Ra is equal to 226 gram per atom. There's missing one. It's easy to detect because according to Mr. Dmitry Mendeleev, the one who discovered the periodic table, that atomic masses will be increased, or increasing atomic number from top to bottom of the group. So we have still missing here. I think it's going to be magnesium. Okay, magnesium have atomic mass of 24.032. And that completes our group 2A in the periodic table. Okay. And now, the time is near, so I face the final curtain. I did it my way. Okay, the next group will be, let's just escape the transition first. This transition from, okay, from 3A to 2B groups. Let's escape for a while. Let's go directly to the right, okay, which is mostly the non-metals group. Okay, so we start with taking into account the B, boron, C, carbon, and nitrogen or nitrogen, oxygen, okay, fluorine, like that. BCNOF. Memorize this also because this is very important in our electronic configuration. Okay, get the point, especially in the study of semiconductors like that or electronics industry. So we need really the electronic configuration to understand the manufacturing of different electronic gadgets and products all over the world. Okay, especially the process of alloying metal to metal, like the whatever. Okay, so we have here B, C, N, O, F. Okay, class. Capital B means buron. Okay, capital C means carbon. Capital M means nitrogen. Capital O means oxygen. Capital F means fluorine. Okay, so out of that five, so let's have description. Okay, okay. Carbon is the most common non-metal in the planet Earth. I'm saying common. Okay, I'm not speaking with the deposits or the contribution to the percentage by mass in the planet. I'm saying common only. Okay, because this is the parent element of all the materials all over the world. That we try to hit any compound, there always product carbon in it because the color is black. So after burning, after fire, so the ashes color black contains definitely carbon atoms. Okay, ashes or whatever. Okay, it could be a tree, still have carbon. When you burn it, there's a black. The black particles presence indicates that is carbon atom. Okay, now description with nitrogen. Okay, nitrogen is inert gas, not reactive, but it can cause asphyxia. Okay, you will be asphyxiated. Okay, if you receive the process known as asphyxia. So, of course, asphyxiated, right? Okay, noun asphyxia. So, this is a disease in which you are suffocated with the presence of nitrogen content. Nitrogen explodes. Nitrogen is not flammable, it's not reactive, but it will explode. You get the point? Why? Because nitrogen is 79 or 78 to 79% by volume in the atmosphere. So it's highly adapted in the atmosphere. Once there's leakage, then the molecules of nitrogen inside the gas cylinder of the nitrogen cylinder will react to the molecules of the nitrogen also in the atmosphere. That's why bombarded, the molecules like that. You get the point? So, if you are the handler of a particular nitrogen, so there's a chance of suffocation. So once you are suffocated, you will be suffering from asphyxia, the disease. Okay, due to this nitrogen. If the nitrogen concentration will go to your blood, problem. Okay, you will develop also the disease called anoxia. Okay, the higher concentration of nitrogen into your blood. Okay, we don't need that. Okay, so we need to keep safe our nitrogen gas cylinder because of these harmful issues. We should not be complacent and taking for granted because nitrogen is not reactive. Then we say, okay, we will put this anywhere like that. Okay, things like that. So, due to poor knowledge, it can kill us. Get the point? Things like that. Okay, that's nitrogen characteristic, no? Okay, so asphyxia. Things like that. Then, but then also, you will, if you are consuming the oxygen into your blood, then problem of aphoxia. Okay? And if you are consuming the blood level of your respiratory, okay, will cause this one, asphyxia. Okay? So nitrogen and oxygen are related to each other. Okay? They are very compatible with each other. That's why we have nitrous oxide, dinitrogen pentoxide, dinitrogen oxide, like that, dinitrogen oxide, the laughing gas. Okay? Then very react to each other. Since we say, right, nitrogen is not reactive, we say a while ago. But bigaon siya when it reacted to oxygen. So, he is very selective. Though, naturally, he is unreactive. So, this is the characteristic of nitrogen. In fact, nitrogen also will react to hydrogen to produce ammonia. But, selective. You know, selective. It will never react to metals. Okay? It will react only to non-metals, such as gases, especially oxygen and hydrogen. But other than that, It's not really that possible, but it depends as long as it is non-metals. For example, okay, nitrogen fluoride. There's also like that, right? Because fluoride in the halogen family, that is not non-metal. So we will say we deviate the concept that nitrogen is non-reactive. Actually, right? Yes, generally non-reactive, but reactive to some or to few non-metals or gases. If that is the case, we don't have nitrous oxide. The reaction of oxygen atom and nitrogen atom, right? So don't limit yourself that nitrogen is unreactive only for the rest of his life. Things like that. Okay, let's change our perception. Okay, that's why we need to receive information about the study of chemistry. You get the point? Things like that. Next will be the oxygen family. Okay, the oxygen. The oxygen is the most bigaon of all elements in the periodic table. Kasi asa na siya mag-igat-igat. Okay? You got the point niya, majuwa niya si Kuan, si fluoride, majuwa niya si kinsa ng mga transition elements, like that bigaon kay siya, guys. Starting from the esophagus, going to your system, maabot ko siya dito, mga oxalates, ay oxygen dito. Maabot ko na siya dito sa mga DNA, RNA, ribonucleic acid, deoxyribonucleic acid, gano'n. Basta, okay, si oxygen. Okay, buhato na siya sa mga fat, lipids, proteins, amino acids. You cannot escape. Oxygen will always be there because he is very abundant. You get the point? The most abundant element in the planet Earth, oxygen. That is the main description of oxygen. If the question will say, which among the elements is the most abundant in the planet Earth? Your answer will be oxygen. But if you will rephrase that, the most abundant element in the universe, you will change that to hydrogen. Why? Because oxygen cannot reach to the universe. It's only in the planet Earth. You get the point? So, we take a look of the description of the question, okay, during our memorization technique. That's why I told you, you need to establish the K words before answering, the adjective, the pronoun, the noun, like that and everything. Okay, things like that. Okay, now, after oxygen, we have also fluorine. Fluorine, ang iyang description is the most electronegative element in the periodic table of all. The answer will be fluorine. It will also come out in different examination. One word only. Which of the 118 elements is the most electronegative? Your answer is fluorine. Okay? So, don't depend with multiple choice. Put that in our brain. Because if we depend on multiple choice, problem. Butikaw, ikaw, butikaw, ikaw. So, it's better to inculcate, retain, engrave, implant, okay, into our brain cells, particularly the cerebrum vortex part of our brain, in which the hippocampus part of our brain is there, in the temporal lobe. So if you study the anatomy of our brain, then you can understand really the parts by parts of this brain. So it's in there, the learning and the memory stocked in the hippocampus part of our brain cells. Okay, that is BCNOF. Okay, now, arito sa boron family. Charot! Okay, let's have the atomic mass. Okay, boron, 10.18 grams per atom. Carbon, the most popular, 12.01 grams per atom. But our teachers dropped the 0.01 because it looks like negligible, 0.01. But I'm just trying to be precise. That's why, 12.01. Okay, nitrogen, 14 grams per atom. Okay, oxygen, 16 grams per atom. Okay, things like that. Fluorine, 19 grams per atom. So these are the atomic masses of our BCNOF. Okay, now, fluorine is not, hindi siya nag-iisa. There are also other elements belong in his banner. Okay, but he is the first honor of the group, just like a summa cum laude in a class, because he is in the top. Okay, things like that. So, another halogen follows him. Okay, never mind with the pronoun, guys. I use him, he, she, because it's difficult for me, the elements have no gender. It's difficult for me to say like that. Sorry. Okay, things like that. So what we cannot say that Florine is a girl, Florine is a man. So let's use any gender in a wait for a while. Third personal pronoun, right? We have first personal pronoun, second personal pronoun, third personal pronoun because I, you is first personal pronoun, then they, it, as, we, third personal pronoun, and then he, she, yes, oh no, second personal pronoun, ang he, she. Okay, so because there are three types of pronouns. So let's qualify. So it's very difficult to qualify. That's why we will use just he, she. Okay? For the purpose of discussion only. Right? Okay. Now, after fluorine, we have chlorine, bromine, iodine, astatine, AT. Now, atomic masses. Okay, chlorine, 35.45. Just memorize the chlorine, guys, because it's very common. This is very common in the process of corrosion or rusting. It will react to iron to produce iron 3 chloride, or what we call as ferric chloride, in the presence of water. It could be rain, it could be water, it could be moisture. Okay, things like that. Okay, so we have bromine, 79.9. Okay, iodine, 126.9. Astatine, 210. So, see, astatine, it's very easy to memorize, 210. Just follow the rhyme. Astatine, 210. So, very easy to memorize, right? So, grams per atom. Okay, that is the halogen family or the halide family. Okay, now we go to our favorite, the noble gases. Right? So, ganun siya. Si neon. Neon light in the streets. Okay. Neon. Charot. Okay. Si neon, na-share ko guys, no? 20.18 gram per atom. Actually, si helium pa sa taas. 4. Helium, neon. Okay. Then, argon, 39.91. Okay. Grams per atom. Argon. Then, we have also krypton. Kr 83.8 krypton, ha? Okay. And then we have the xenon, 131.3 grams per atom. And then we have the last, radon. Radon, Rn. It's not Rd, ha? Rn. So we need to say the gram atoms will be very easy to memorize also. Triple 2, 222. Gram per atom. So it's very easy. What is that atomic mass of radon without looking the periodic table? So your answer will be 222. With condition talaga, without looking periodic table. So 222. Okay, things like that. So manatano sa mga gases. Okay, ano na yun. Okay, so let's go to metalloids. Labos ko na metalloids, guys. Okay, so we have metalloids. We have germanium, silicon, polonium, arsenic, ES, right? Arsenic, okay, things like that. And also phosphorus, things like, oh no, it's not, cesium. Okay, cesium. Wait, there's still another one in there. I always mix this metalloids because these metalloids are mixing in the metals kasi. You got the point? So it's very difficult to trace. You got the point? So, germanium is 78.96 gram per atom. Silicon is gonna be, okay, silicon is gonna be 28.09 grams per atom. Okay? 28, ha? Okay. Polonium is 209 grams per atom. Arsenic is gonna be 74.92 grams per atom. And cesium 138.9 grams per atom. Things like that. Okay. Okay? It's very clear for the metalloids. Okay. Now we go to, ay nakakaloka. we go to some of the actinide series and lanthanide series. The last two rows in the periodic table isolated from the top. These are from the bottom. Okay, things like that. So, we have 26 artificially prepared elements or radioactive elements. Remember, 26. Okay, you got the point. 26 plus 92. How much? 26 plus 92, 8. So 118. So 92 are naturally occurring elements. 26, okay, are really artificially prepared. Things like that. You got the point? Things like that. Okay. Now, let's go to the artificially prepared or radioactive. So we start with lanthanum. Okay, Ln is equal to mga palangga kung hitad for this. So 189.2. Okay. So, you know guys, sometimes you will forget the very slight and you should remember the technique. Oh, it's gonna be like that because there's the same. Oh, let's do it slightly different. So you will adjust immediately by your brain cells. Okay, things like this. So 189.2. Okay, because it's related to the cesium kasi. Okay, that's why you will adjust things like that. Okay? But still correct me if I'm wrong guys, because I'm not also a living photographic memory. Charot! So I cannot also memorize all. So actinium, 227 grams per atom. Okay. Americium, discovered in America. That's why americium. Okay, we have 243 grams per atom. Okay, things like that. And we have also laurentium, discovered by Mr. Lawrence. Okay, we have Lr. We have 262 grams per atom. We have also nihonium, the only element discovered in Asia, specifically Japan. Okay, discovered by Yusoki Morita. Okay, in December 30, 2005. Officially confirmed as an element in the periodic table. So nihonium, atomic mass is 286. And the half-life is very quick, 10 seconds only. Okay, 286 grams per atom, right? And we have the unonoctium, UN, things like that. The atomic mass is 294 grams per atom. Now, if the question in the exam will say, what is the maximum atomic number in the periodic table? So you will answer 294. Because there's no such 295. That's the stopped. Okay? So the question, it looks like strange, right? But it can be. Okay? Because expect the unexpected in the examination. So what is the maximum atomic mass of an element in the periodic table? Obviously, unonoctium. Because unonoctium is the last element in the periodic table. Okay? Things like that. You got the point with atomic number of 118. And atomic mass of 294. Okay, so we have thorium, TH, 232 grams per atom. Uranium, really guys, I love uranium, char. Okay, we have 236. Uranium is the heaviest element in the planet Earth. Heaviest element in the planet Earth. Okay, element in the planet Earth. Okay, so half of it are used to produce atomic bomb explosion. Okay, the first thermonuclear explosion by using half of the uranium energy was discovered by Mr. Enrico Fermi. Enrico Fermi. Enrico Fermi. So he discovered the element fermium. Okay, like that. Okay, so who discovered the first atomic bomb explosion through thermonuclear explosion by using half of the high energy uranium? The half of it. Okay, it's gonna be Enrico Fermi. Okay, things like that. Okay, so he has also element discovered fermium. Okay, ganon. Diba? Okay, so what is the atomic mass of fermium? Okay, can you still remember? So it's gonna be 257, right? Okay, 257 grams per atom. And that's why also, guys, of all the radioactive elements, only fermium have 20 isotopes. Too much. You get the point? Too much isotopes, starting from isotope 241 to 260. So if the question also in the board examination in the future, which among the elements in the periodic table have 20 isotopes? Your answer will be fermium element. Okay, things like that. Discovered by, okay, Enrico Fermi. Ganon. Okay, so 250 grams per atom. Muna na siya. Okay. Muna na siya ang mga radioactive. Napagita is radium. IR is 192.2. Diba? Grams per atom. Napagitay ko an guys, thallium, Ta, 204 grams per atom. Ganon. Okay, any questions so far? For this radioactive elements and artificially prepared elements from lanthanide series and actinide series. Okay, so just comment down below in the comment section if you have some also to share with me, right? Okay, I think also, no, it's not radioactive, the platinum and the palladium. Okay, and the titanium, it's not radioactive, that's naturally occurring. Okay, sorry. Okay, so now speaking for that, so we need to introduce the atomic mass of palladium, titanium, and the other one is platinum. Okay. Titanium. This is very popular. In fact, there is one title of the song Titanium, right? Set the loss, I was control, I was the titanium. That's titanium. So titanium element, Ti. Ti ba siya, guys? Titanium. Correct me also if I'm wrong, ha? So it's gonna be 47.87 grams per atom. Palladium, Pa, I am sure. No? Really? Palladium. Okay, because sometimes you will be confused with PD, PA on the letters. Okay? So correct me if I'm wrong also, maybe PD also, ha? So it's very slight. Okay, so it's gonna be 106.42 grams per atom. Or concentration is in the atomic mass kasi. Okay, then we have platinum PT. Sure ko anong platinum PT is equals to 195.08 grams per atom. Okay, these are the atomic masses of titanium, palladium, and platinum. Now, these three elements or metals are chemically bonded to produce an aircraft or airplane. The construction metals of that airplane is basically like platinum, palladium, and a little bit banded with titanium. Just review also, okay? Because I read that also so many times. Okay, platinum, palladium, like that mixture. Okay, percent, whatever. Okay, things like that. But there is, I think it is more on platinum, things like that. Okay, just review that by yourself also. Okay, the metals, construction of materials for airplane. Okay, the metal parts of an airplane. Okay, things like that. So, di ba, how you school the elements? So, without it, then we cannot go to another country because that is the wall of the airplane, that elements. So, we will give thanks to Mr. Antoine Lavoisier, the father of modern chemistry. Right? A Russian chemist. That's the father of modern chemistry, Anton Lavoisier. Okay, things like that. And now we go to the most talk about elements. Let's start with the elements that mostly bonded in electrolytes, in electrolysis topic, meaning using chemicals to produce electricity. For example, battery, the anode, the cathode. So it composed of a metal like a zinc, a copper, like that in the terminal. That is element, that is metal. So that's why elements or chemicals used to produce electricity. An example for that is a battery. You get the point? And another also method to produce electricity from chemicals. And the topic in chemistry is electrochemistry, specifically electrolysis. Because if we have hydrolysis, we have also electrolysis. Our target is to produce electricity from chemical reactions or using chemicals. Okay, things like that. Okay, going back to the most common, ayun sa transition or sabol. So we have here copper, popular, right? Copper also in the roof mixture, alloying of copper, zinc, iron, so galvanized iron sheet. Like that, you get the point. So copper, 63.55 grams per atom. Okay, zinc, 65.38 grams per atom. Like that, no? Okay, bismuth. Wow, I love bismuth. I miss him. Chad. Bi is equals to 208.98 grams per atom. Oh, I love also cobalt. Wow. Co is equals to 58.69 okay, grams per atom. Cobalt. Nickel. Wow, nickel, right? Nickel is 58 okay, 83 gram per atom. Okay, things like that. You got the point? So slightly 58.93. Put that in your brain cells that cobalt and nickel are closer to each other. Okay, it's gonna be 58.93, 58.83, but let's just choose 93 based on the correction of my brain cells. So 58.93, like that. But cobalt 58.69. So we have also chromium. Cr is equals to 52 flat. I make it a flat because I rounded off the point something. Okay, so that it will match the tellurium, Te. Tellurium is 52 also. So that during my memorization, it's very easy for me to remember the tellurium and chromium. Both have atomic mass of 52 grams per atom. You get the point? Things like that. And now we have also indium. This is no connection with India, huh? Because it looks like an element discovered in India. No, it's not. Okay, so indium is 114.81. Okay, things like that. Indium or In symbol. Okay, now we go to molybdenum, Mo. 95.96 grams per atom. Tungsten, W. 184.83 grams per atom. Okay, our favorite iron. Okay, Fe 55.85 grams per atom. Right? Silicon, our favorite also, present in our land surface in the compound called silica, SiO2, things like that. Okay, silicon is the major component of sand and land, things like that, silicon. So it's gonna be 26.98 grams per atom. I remember this because this came out in the board examination. The largest percentage element found in the soil, it's silicon. Okay, things like that. Because of silica, sand, chuachucho, okay, things like that. And we have, after silicon, we have phosphorus. Wow, I love phosphorus, no? So 30.97 grams per atom. Now let's go to sulfur, 32.2 grams per atom, like that. Okay? So what else? Think of an element, then I will give you the atomic mass on the spot. Okay? Because sometimes it's very difficult. I also remember, I also give the atomic mass. Then you can suggest and I will give. Okay? So what else? Cadmium, Cd, is equals to 112.41 grams per atom, right? Arsenic, 74.92. Things like that. Okay? What else, guys? No? Okay, I think germanium, okay, very easy, germanium, 78.96 grams per atom, right? Okay, selenium, Se. Selenium is gonna be 72.64 grams per atom. So any elements, guys, then I will give the atomic mass on the spot without looking the periodic table. without Google search engine, and without also books, right? So this is only to sharpen our memorization despite of our age. I'm old, but I'm trying my best to become young in terms of effective memorization. Okay, things like that. You get the point? Nothing else? Okay, so transition. Okay, copper, zinc, nickel. Wala kay cobalt, no. Chromium, una na dyan. Okay, manganese. Manganese is 54.94 grams per atom. So what else, guys? Okay, don't be bothered with this, ha? This is only an advantage or a bonus or a plus factor during your chemistry because it's easy for you to compute for the molar mass without looking the periodic table, things like that. Automatic na kang kuha na yun. Okay, smooth flow, tuloy lang ang ligaya. Whereas if you don't memorize this, you will pakli-pakli ever. Then it will consume your time. Things like that, especially the computation of empirical formula, molecular formula, like that, molar masses, molecular weight, okay, things like that. Okay, but don't be bothered because usually the famous only, the CHON, meaning the protein family. Okay, the protein CHON, the carbo CHO. Okay, and then the, what's this called, guys? The hormones, sometimes you will add S or tunes. Hormones and the amino acids. Okay? Or an enzymes also sometimes. Okay? Things like that. But basically, ang protein o carbohydrates. So carbohydrates, CHO. Carbon, hydrogen, oxygen. Protein, carbon, hydrogen, oxygen, nitrogen. Bingo. Okay? So, pwede lang kami siya yung mga memorization sa yung atomic masses. But, the benefit of a doubt, if you want to be comprehensive and detailed, then memorize at least 50 elements up of the atomic mass so that you will never look anymore at the periodic table. Get the point? So, at first, it looks like very strange or very tasky because of point something. Because, as I told you, I hate numbers, right? And I'm not really that superior in mathematics, though I am average, and above a little bit average, but not superior, okay? But you know, sometimes I hate it, but I don't have a choice, okay? Because it's really necessary and part of science to do a lot of calculations and computations, and I started to love it. So if I don't love it in a way, why I really remember this atomic masses? Okay, so if you do by heart, then you can remember. Though it's not really perfection, but some things like that. You get the point? Okay. Do I speak it clearly, guys? Any questions so far? Class, for this particular topic of atomic masses and atomic weights? Okay. Ganon. Okay, what else? Parang naano ko na lahat, no? Okay. So, sige. Wala siya. Okay, so if I will say, calculate, example na tanong. So, calculate the molecular mass of creatinine. Strange. This is a very strange question like this. So, you should expect the unexpected because sometimes they don't give the chemical formula. And you'll be the one to remember. So, creatinine. So, what is a creatinine? A creatinine is a very essential protein that we need in our muscles so that it gives energy to perform work, to be active, so that we can eat, we can walk, we can raise the objects up and down, we can do things in life. So without creatinine, we don't have energy because this is the protein needed in our muscles to gain energy. Any questions so far? And that's very clear. Okay, now, once the creatinine will die, because it's just like a human being, this is just a life cycle. Birth, living, and death. So this is the cycle of the humanity. Okay, so if we grow, okay, then old, and then body will die. The protein also, or different substances in our body, follow the same cycle. When the creatinine will die, it will become a dead cells. Okay, now, if your liver is not functioning well because of a lot of issues, he or she cannot detoxify, the presence of this dead cells creatinine, then it will stuck in the liver. You get the point? And it will go to the bloodstream. That's why the doctor will get the sample, or the medical technologist, to get the presence of this creatinine in terms of milligrams per deciliters. If you try to look your medical certificate, always expressed in milligrams per deciliters or millimole per liter. It's either of the two unit of measurements. Just check it out, okay? Things like that. Then, if these dead cells will not be detoxified, it will harm your liver. It can cause fibrosis, inflammation of your liver, and your liver will shrink and will be wounded, and you will suffer liver cancer. So, your creatinine must be regulated to 0.6 to 1.2 milligrams per deciliter. Beyond 1.2, problem. Okay, things like that. But less than also 0.6, problem. Because that is not the desired creatinine that our muscles need. Because that's the range. So in between to this, we got a point, things like that. That's creatinine. Now, going back to the chemical formula, because we cannot compute the molar mass and the molecular weight without the chemical formula. What is the chemical formula of creatinine? Anybody? So this looks like a difficult chemistry already, right? Okay, so things like that. So this is under organic chemistry, but still we have the same connotation. Wow, connotation. We have the same insight that we need to determine the molecular weight, regardless of what type of chemistry is that. Organic, quantitative, general, whatever, clinical chemistry, medical chemistry, whatever. So we are trying to compute the molecular weight, right? So creatinine, the formula of creatinine is 4 atoms of carbon, 9 atoms of hydrogen, 3 atoms of oxygen, okay, things like that, and 2 atoms of nitrogen. So tune, as I told you, protein is tune. C-H-O-N. The only difficulty here is the way how we memorize the atoms. It looks like strange. In my part, I need to remember the gap like that, the even number and the add number. If you can still remember our algebra, right? Add number 1, 3, blah blah blah, right? 5, 7, then 1, 1. Okay, then even number 2, 4, 6. In that way, you can easily memorize. Oh, there's only two even number there. And then after the gap also, gap. Or from 3, only 1 gap between O and hydrogen. You will do that in your brain cells. Okay, during memorization. Okay, because you will do that in your mind when you study. Okay, so it's easy for you. And the gap here is 5. Okay, 4 and 9 like that. And then slowly, as you enjoy your subject, then you love it, you enjoy it, you have the passion in doing it, you are devoted, especially you are the target to become a licensed chemical engineer really, then it would really, lucrative and profitable to do that. Okay? You get the point? So there's meaning why you do that. If you put meaning in everything you do, so it is very beautiful to do that thing or to do that task. Then if you don't put meaning in everything you do, sometimes it will just pass away. You cannot remember. I think this is natural in everything that we do in our life. If we don't put our heart into it, it looks like no substance at all. So it's just the same also in studying. You get the point? So things like you just put that in your heart and love it. And once you love it, you have the willingness to learn slowly and then baden it, or next to you, it will become your culture and attitude. Okay, now it will increase your knowledge day by day, since knowledge is a continuous process. It will never stop. It will just stop until your last breath. Okay, now this is the formula of creatinine. So we get the molecular weight. So molecular weight, molar mass are just the same. Okay, don't be confused. And also molecular mass. But what used often or what used regularly in our class is always molecular weight and sometimes molar mass. But we found strange if it is already molecular mass. But it's just the same. Only the adjective changed molecular. Because once you say molecule, it has to do something with a compound. Okay? Atoms plus atoms plus atoms bonded together, it will become one molecule. You get the point? Things like that. That's why if I will say hydrogen gas, so things like that. There are two atoms of hydrogen. But in this case, we cannot say a molecule because this is still monoatomic, meaning single element. So the molecule terminology is applicable to a compound. So that we will make it clear. If you use element, you will never say molecule. You will never say the molecule of sodium. No, it's not. Wrong grammar. Because element is only single. It's only made up of one atom, mga palangga. So how can you say it's a molecule? So we need to say we should be appropriate and precise where to use this terminology in correct manner. Tapos this is what we call chemistry grammar or science grammar. If we have English grammar, we have also science grammar. So we need to be smart in this aspect. Okay, if we want to become a scientist in the future. Wow, if we want to become a scientist in the future. Yes, okay, it's gonna be like that. So, what is the molar mass? Charot, oy. Okay. List one by one. Carbon, 12.01 gram per atom. Okay. Hydrogen, okay, 1.008 grams per atom. Oxygen, 16 grams per atom. Nitrogen, 14 grams per atom. Now, take note the subscript. 2, 3, 9, 4. Now, by basic concept, subscript multiply by coefficient. What is coefficient? If you remember math, this is a numerical number put beside the variable or numerical number that's in math. In chemistry or in science, that is the numerical number or figure or digit put beside element and a compound. Saro di mo kasabot. Okay, that is coefficient. Okay, so if you multiply the subscript and that coefficient, that is your atom. Okay, things like that. You get the point? That's why atom and a mole, it's not the same. Okay, you get the point? Things like that. Oh, ganun siya. So we are computing here the atoms. So that atoms plus atoms, it will become the molecular weight. So molecule na siya. As I told you a while ago. So atoms plus atoms will be molecule. So that's why molecular weight. Okay, things like that. Okay, so 12 times 4. Okay, 4 ang subscript sa carbon. 9 ang hydrogen. So times 9. Oxygen times 3, nitrogen times 2. Okay. What this implies, guys? For example, I have 12.0 gram per atom. What does it mean in basic understanding? We will say, in every one atom of carbon, it is having an equivalent mass of 12 grams. That's what it means for this gram per atom interpretation in English. Again, if I have atomic mass of 12.01 gram per atom, what does it mean? It means in every one atom of carbon, there is an equivalent mass of 12 grams of carbon. So this is interpretation so that we can understand. We need to interpret the unit of the measurement before we will go further so that we can easily calculate if there's a lot of chemical reactions, stoichiometric amounts, because sometimes like that, if the carbon will double at 27 degrees Celsius, what will happen to the carbon? What is the mass of the carbon? So you use that concept in every one atom of carbon, then you have 2 times 2, 2 times 3, like that. Things like that, okay? So actually this is not also taught very well in our high school, in our college. This is only my own. Okay, as I progress in studying a lot in my profession in BS Chemical Engineering, because I spent all my time, most of my times in the library, things like that. Okay, so 12.01 times 4. Okay, things like that, mga palangga, no? Okay, so 12.01 times 4 is equals to 48. Okay, no? Okay, na natin 48.12. Okay, 48.12. This is gram per atoms. Other teachers also putting directly gram per mole. Okay, I don't have the time to correct because it depends on how we manage to discuss, right? But this is really the correct. Okay? So I don't have time to correct some teachers because they're still using gram per mole also, even though element. Really? Okay? So they don't know how to distinguish between an element and compound in using the unit of measurement. Because once it is an element, you use atom because that is element is made up of one atom. It's not made up of a mole. So you will never say gram per mole. So gram per mole only if it's already a compound because it's bonded of different elements. Okay? So this issue is not really clear. If this is the issue is not also very clear to the teachers, how much more with the students? You get the point? Things like that. Okay? So, trust me. Okay, get the point. So, 9.072. Okay, 9.072 gram per atom. It's not gram per mole, ha? Okay, things like that. Okay, 16. Ako naman na siyang gitoki guys para masabtan dyan na itong kinatibukan. So, 16 times 3, we have 48 grams per atom. Okay. Now, nitrogen, 28. Now, add this all. Atoms, 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 atoms. So, by definition in chemistry, atoms banded together will become a molecule. Okay. Things like that. And the unit of molecule is gram per mole. It's not gram per molecule. That's why. That's why gram per mole arrived in the book. Because of that. You get the point? So, atom plus atoms will be molecules. Okay, so this is molecular weight. Okay, since we cannot say gram per molecule, this is a ratio that this is gram per mole. Okay, things like that. You got the point? Okay, nahimo na siyang gram per mole. Okay, so it is also called as a molar mass because of the representation of the mole in the denominator. So we can designate also molar mass, molecular weight are just the same. Okay? You get the point. Say, adali mo muna yung molecular mass, molecular weight, and molar mass. Okay? Things like that. Moro dyan na siya per me guys, no? Magbalik-balik. Okay? So, it depends on how we interpret June. Things like that. So, 48.12 plus 9.072 plus 48, charos, plus 28. So our molar mass, molecular weight, and molecular mass is 133. Okay. Since we need to agree on using terminology, so if we are convenient by using molecular weight, we will use that all throughout in our study. Our purpose only so that we can have another term in case of any emergency. Wow! In case of any examination in the future that use another term. Okay, so that's gram per mole. So this is now 133 with 19 gram per moles of creatinine. Okay, the creatinine is a bad protein in our muscles. Okay, after the cycle. Okay, things like that. Okay, so if we have higher levels of creatinine, it can cause the malfunctioning of our liver. Okay? It's a point. Very important because the liver will do the detoxification. It will remove the toxins, like that, whatever. That's his job. Okay? So if that is the case, we have so many diseases if our liver will be malfunctioning. You get the point? So we will need to take care of our liver. You get the point? Things like that. Oh, diba? The largest internal organ in the human body. I'm saying largest internal organ in the human body. I'm not saying the largest organ in the human body because that is the skin. Is the answer for that. Okay, take note. The largest organ in the human body, the answer is skin. But I'm saying the largest internal organ in the human body is the liver. Okay, so take note the adjective like that. So that magdali-dali kay more na tumadunggan, so we will be wrong. You get the point? So we will be particular and specific in English language as well. You get the point? Things like that. It would be a great benefit during examination also. Because most of it expressed in English language. It's not expressed in Bisaya and Tagalog. You see an examination that expressed in Bisaya, tell me honestly, if you can tell me on the spot, then give me link that shows examination, world class examination or employer examination is expressed in Bisaya. Paputol ko sa niyo kung may Bisaya nga question. Kung computer ninyo ang kuan wala jud. Okay, you get the point. So that's why we need to be good in English. We should, because that's really the basic requirement in the interview like that. Okay, to excel. Okay, I'm not telling you to be good in communication skills, at least in the written or in reading, things like that. You get the point? Things like that. We need to balance our English language capability. Okay, things like that. Okay, the rest will follow na siya. Okay, any questions so far? Nothing, right? Okay, so I hope you like this particular topic. You can subscribe my YT channel, and I'm very happy and grateful if you can do that for me. And my happiness will be extended to the heaven as well. Okay, bye-bye. God bless everybody. See you later. Have a beautiful Sunday. Babush. And now, let's go to music. Diba? Diba, guys? Music is touching our soul. Charot. Okay. Diba, guys?
It's really to tell.
Diba?
The Bluetooth device is ready to pair.
Let's do the
The
music.
Bluetooth device is connected successfully.
Music.
The Bluetooth device is ready to pair.
I have often told a story.
Device is connected successfully.